word2vec is popular, but people don't use that directly anymore. There are a lot of following up works. We will talk about two popular ones. The first one is called FastText. The idea is here, the English word usually have a lot of internal structures. Like, for example, if you know the meaning of a dog, you kind of can guess what the dog means and what the dog catcher means. Okay, so then, like, if we know this structure information, so we can leverage this structure information to help to understand this word. So now, in the FastText, each center word is presented by a set of subwords we have. So what do we do here? For example, given a word called where, we first adding two spatial charts on the beginning of the word and end of the word. And then get all these n-grams for this word. The n-gram is just a segment of this word have a length equal to n. So if we pick up n equal to 3 here, we will get 5 n-grams here. So you hope that each segment kind of can be like present something, and we can, for the other words, we can learn the embedding for this grams, n-grams, and can generalize to the other things. So this is pretty useful, like for very long but infrequent words. Like this word, like I just Googled like the longest English words we have, and I guess nobody will have this one appears in the dictionary you have. But you can see that a lot of like micro, like I don't remember, I don't recognize this thing, but you have a lot of segments here. You kind of guess like maybe kind of similarity between this word to other ones. So FastText is pretty useful for like the language the words have internal structures. Like a lot of European language have such structures, but doesn't apply to the other ones like East Asian language doesn't have internal structures in the word, so it doesn't apply to that. So what it's exactly doing is like, given the word W, we compute a GW, which is a union of the subset of these words, like with the length equal to 3 and 6. For each word, we get all these 3 grams, 4 grams, 5 grams, 6 grams, make it a set, make a union set, like denoted by GW. Then each subword we have its own embedding, like U. Then the center word is kind of the sum of all these embeddings of the subwords. But that's all. Like you just apply the normal skip grammar model, you get the FastText. Okay, so this is the FastText is good at very long words, infrequent words, and you have internal structures in the word. The other model is called word embedding with global vectors. A little bit different. A little bit math here again. So we first denote by Qij, which is the conditional probability of the I. Well, it's the ith word. It's the ith word as the center word, and the j as the conditional word. So I is the center word, j is the condition, is the context word. Qij is the conditional probability. So then we can think about the likelihood function we have is along the sequence. Every time pick up the center word and pick up the bunch of context words. So you can, on the other way, you can rewrite as for each pair ij, I can compute the frequency or how many times it appears in the context, and just have pij and times and multiply by the count we have. So we can rewrite another form. Like this is one from the time series form, the other one for like, the frequency term. Like think about like doing FFT on the sequence. So now we can rewrite the negative log likelihood function as this one, but if we compute xij, which is the ij pair, how many times it appears in this former log likelihood function. So these two forms are equal to each other. So the second term, we first iterate all the center words and iterate all these context words, and the count times the log of the conditional probability we have. Okay, these two are equal to each other. Second one, we look at we can further rewrite. We can make xi will be a sum over j, all the context words we have of xij, and the pij, which is xi divided by xij, which is pij is the frequency actually appears the pair in this corpus. So we can rewrite as, we can make xi before the second sum operator, and the internal one is like sigma pij times log pji. Both pij and qij are probabilities. Like given it's a conditional probabilities like for I as center words. So the second term is a cross entropy. We saw about is measure the difference between two probabilities. Okay, so think about like we rewrite the word-to-vec function as this way, then we can change it. So what we will change, the GloVe do three things change. The first thing is like it replaces the cross entropy as the log square loss function here. So the log pij minus log qij pi, but pi is a simplified version. Like we change the loss function here, and we make qij not the probability, actually just the exp. We just remove the denominator. Make it, again, it's easy to compute. And we also adding a bias term, like we only have a vector, we don't have a bias term to count all this, the prior probabilities, we have a bias term. And finally, we replace the weight xi with some functions hij with within 0 and 1, and we obtain the final object function here. So again, this is a kind of linear, like it's a SVD function we have. It's kind of still very similar to what we had before, given embedding, two embedding and doing interproduct. So that's kind of, it's called global vectors. I don't remember what global counts. Maybe the, maybe bi, maybe this the BICJ anyway. But I forgot where this goes. But again, so this is two popular models we have. The first one is like give a subwords. The second one just rewrite the loss function to make it from cross entropy to log square loss. So that's all. So I think we have